Alright. In this session we are going to continue the topic permutation and combination. In the last class we had discussed from question number 1 till 4 and we have discussed about the concept of arrangement and factorial, right? In today's class we are going to start question number 5 from the same exercise 10.1, 10.2 from your new book. Alright, it says you have a 5-digit numbers are formed using the digits 2, 3, 4, 5 and 6. So we have numbers 2, 3, 4, 5, 6. Each digit may only be used once in any number. Find how many different 5-digit numbers can be formed. For the first part, you know that it's 5 factorial. Alright, so 5 factorial numeric value is 120. For the first part, the answer is 120. For second part, it says, how many of these 5-digit numbers are even? We have discussed the case of even in our last session. If you have an even number, you have 5-digit numbers. Now, for the even number, the possibilities are either I have 2 at the last, right? If 2 at the last, then it is an even number, or if 4 at last, then it is an even number. So that means for the last digit we have 2 options, either it's 2 or 4. So this 2 is defined by 2 options we have. Alright, it's not the 2 numeric number, it's 2 options we have, either it's 2 or 4. And for the rest 4 numbers there is no restrictions. Alright, so we have 5 numbers, right? 1 number has been occupied at the last. The leftover numbers are 4, so it can be 4 factorial. So your answer will be 2 times 4 factorial. 4 factorial is 24. 24 times 2, it's 48. In fact, we don't have 2 options, we have 3 options, right? Cos 2, 4 and then 6 as well. So at the last number we have 3 options and then it's 4 factorial. So now it will be 3 times 4 factorial, which is equals to 72. So 72 is your answer. In the last explanation I have by mistake missed the number 6, which is also an even number. Alright, so part B answer is 72. For part C, it says greater than 40,000. So we have a 5-digit number 1, 2, 3, 4, 5. If the number is greater than 40,000, that means for the first number either it can be 4, either it can be 5 or either it can be 6. For the first number we have 3 options, right? And for the rest 4 numbers it can be any number, so it's 4 factorial. Again you have 3 times 4 factorial, which is 72, and that is your part C answer. For part D, it says in the part D, even and greater than 40,000. Alright. So now there are 2 conditions. The number must be even, 3, 4, 5, and it is greater than 40,000. The problem is if you are considering about the even number, so we can say that either for the last number either we have 2, either we have 4, or either we have 6, right? And if the number is greater than 40,000, 4 and 6 can be used as the first digit as well. So now the same numbers are using on both of the numbers at the end or at the beginning. So what I think is the easiest way, I will make cases here, right? 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5 plus 1, 2, 3, 4, 5. Alright. So now I am going to apply the conditions for even numbers. It's 2 for even number, it's 4 for even number, it's 6 for even number. What is the benefit? Now we are quite clear about the first number. Since we have meet the conditions of even number, that means for the first number we have all 3 options, 4, 5 and 6. For this one we have 3 options, 4, 5 and 6, right? That means we have 3 options here. So the answer will be 3, and these 3 numbers are 3 factorial. So we can say that for the first part it's 3 into 3 factorial, right? Plus for this one. Now 4 is already being used at the end of this number, so we cannot use 4 at the beginning. So now the options for the first number is either 5 or 6, so we have 2 options. The remaining three numbers are 3 factorial, so now we have 2 into 3 factorial. Similarly, for last one we have two options, so it's 2 times 3 factorial. So I find it very easy to understand such type of questions which have two conditions simultaneously. So 3 factorial is 6 times 3 is 18, plus 3 factorial is 6 times 2, 12, plus 12. 12 plus 12, 24 plus 18 gives you 42. And that is your final answer. So that was your homework question as well. If you are clear in this, then it is very good. But if you have a doubt, so you can note down the solution in your copy, and you have a time of 2 minutes. So start. Alright, I hope that all of you had done it. After that, moving on to the next one, it's question number 8. Find the number of different 6-digit numbers which can be made using the digits 0, 1, 2, 3, 4, 5. Without repetition, assume that a number cannot begin with 0. Alright, so first part we need to find out the number, 5-digit number which cannot be start with 0. And for part B, how many of the 6-digit numbers in part A are even. So first we need to give it a try for these two parts, and you have a time of 5 minutes to attempt these two parts, then I will tell you the correct answer. So start. Alright class, for the first part we have we need to find the 6-digit number 1, 2, 3, 4, 5, 6, right? That is first part. The condition says that the number cannot begin with 0. That means in those 6 numbers, 1, 2, 3, 4, 5, 6. For the first place, we have 5 numbers available. Alright. Now, we have 6 numbers. For the first place, there are options of 5 numbers. Either it can be 1, 2, 3, 4, and 5. Out of 6, one number has been occupied here. Now the rest 5 numbers can become in any order. So that will be 5 factorial, right? So the answer is 5 into 5 factorial gives you the value of 600. Alright? Now for part B. How many of the 6-digit numbers in part A are even? 1, 2, 3, 4, 5, 6. If the number is even, the number of possible outcomes for the last number, either it can be 0, either it can be 2, or it can be 4. So there are 3 possible outcomes for the last number, so we need to multiply by 3. Now what about this one? Total we have 6 numbers, right? And among those 6 numbers, there is only one number which can be placed at the last, so the rest over part is 5 factorial. So we have 5 factorial into 3. So 5 factorial is 120 times 3 leads you 360. That is your part B answer. Alright, but there is one slightly mistake here. And what is the mistake? Since it is mentioned here that in part A, alright, it means that for the first part we cannot include 0 in it, right? We cannot include 0 because it is stated in the question that the number cannot begin with 0. So for the first part we have all the 5 numbers except 0, right? Now we have again different cases. Why? Because these 3 numbers can be used at the end as well. So I will make cases here 1, 2, 3, 4, 5, 6 plus 1, 2, 3, 4, 5, 6 plus 1, 2, 3, 4, 5, 6. For even numbers we have either 0 at the end, either we have 2 at the end, or either we have 4 at the end, right? For the first part here, right, for the first part the numbers cannot be a 0. That means we have 5 options here, right? Out of 6 numbers, 2 numbers are occupied. That means the leftover part here, it's 4 factorial. So for the first one, it's 5 into 4 factorial plus. Now for this case, 2 we have already used at the end, and 0 we cannot use at the beginning. That means for this one, how many options we have? We cannot apply 0 here, we cannot apply 2 here. That means the number of options we have, it's 4. Alright, and the rest options are 4 factorial. Similarly for the last one as well, it's 4 and it's 4 factorial. So 5 into 4 factorial plus 4 into 4 factorial plus 4 into 4 factorial. So when you solve all these conditions, you will get the answer 312. That is your final answer. Now the difference between this part and the approach that we have applied in previously, the condition is clear here that the number cannot be started with 0. That is why we need to make 3 cases here. Alright. So these cases technique is quite simple and easy to understand, and you can easily get the answer by just making these cases, right? Alright, after that, moving on to the next question, it's question number 9, and I hope that all of you are getting the concept of permutation and arrangement here. Now in question number 9, it says that 6 girls and 2 boys are to be seated in a row. So that is a case to arrangement in a row. Find the number of ways that this can be done if the 2 boys must have exactly 4 girls seated between them. Alright, so that is a tricky case, right? At first, I'm going to plot the caches here. So it's 1, 2, 3, 4, 5, 6, 7, 8, right? We have total 8 students. The condition says that the 2 boys must have exactly 4 girls seated between them. So let's suppose the first one is a boy. 1, 2, 3, 4, and this one is a boy. Right? So there are 4 girls seated between them. So how many cases are there? That is my first case. If my boy sits here, the next boy sits here, right? And the last one, if the boy sits here, so the next boy sits here, and these places covered by the girls. So there are 3 placements among those these 2 boys can be sit, right? So that is an initial point for you to start up this question. After that, you need to think about it, give it a try, and then I will explain you what is the right answer. So you have a time of 5 minutes, give it a try, start. Alright, so I hope that you had done it, and what I am going to do, I will explain you in detail. So let's suppose I am going to make 3 cases here because we have 3 possible outcomes, 3 possibilities we have. 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3, 4, 5, 6, 7, 8 plus 1, 2, 3, 4, 5, 6, 7, 8. For the first case, I am saying that this is my first boy and this is my second boy. Among those we have 4 girls and 2 girls, right? Now for this case, this is my first boy, this is my second boy. We have 4 girls exactly between them. And for the last one, we have this boy and we have this one, right? After that, when you observe that these 4 girls can be sit in any order, these 4 girls can be sit in any order, and these 4 girls can be sit in any order. Alright, so up till now, what is my working? We have 4 factorial of the girls, right? We have 2 factorials. Now why we have 2 factorial? Because let's suppose this is my boy 1 and this is my boy 2. So these 2 boys can swap their places, right? Either it can be boy 2 or it can be boy 1. So for all these cases we have this simple approach that these 2 boys can be swapped their places. So it's 2 factorial into 4 factorial. It's 2 factorial into 4 factorial. Alright, after that, if you observe that these 2 places are empty, right? These 2 places are empty. So these 2 girls can be sit in any order. So that will be into 2, into 2, and into 2. And at last, we need to add all those 3. So for the first one, it's 4 factorial 24. 24 times 2 times 2, that is 96. So we have 96 plus 96 plus 96, which leads to the answer 288. Alright, so this explanation here, that is a very summarized explanation, and I have break this explanation into 3 components so you can understand it clearly. Alright, moving towards the next question, it's question number 6. It says 3 girls and 2 boys are to be seated in a row. Find the number of different ways that this can be done if a girl and boy sit alternately. Alright, So for the first part, you have a time of 2.5 minutes. Give it a try and then I will tell you the answer. So start. Alright. So we have 3 girls and 2 boys. It means that we have total 5 students. So 1, 2, 3, 4, 5. Alright. It says the girls and boys sit alternately. So let's suppose we have girl at the first place. We have girl at the first place and then we have boy. Then we have girl, boy and girl. Alright. Now let's suppose that we have 5 girls. 1, 2, 3, 4, 5. So we have 3 girls. Sorry. We have 3 girls. So for the first option of girl, we have 3 options, right? We can tell any of them to sit on the first place. So for the first one, we have 3 options. Let's suppose that this girl has been seated here. For the second one, we have 2 options. The leftover only 2. So we have 2 options, and for the last one, we have 1 option. Similarly, if you have boys here, so for the first place of boy, you have 2 options, and for the second place, you have 1 option. So what you got? You got 3 into 2 into 2 into 1 into 1. 3 2s are 6, 6 2s are 12. That is your first part answer. For next part, B. A girl sit at each end of the row. Alright, so we have 1, 2, 3, 4, 5. Girls sit at each end of the row. So there is a girl, there is a girl, and now you need to find it by yourself. First, give it a try. Time is 2 minutes. Start. Alright, so it says girl sits at each end of the row. So for the first girl, you have 3 options, right? And for this girl, you have 2 options. The leftover part. How many students are left behind? Now listen. We have total 5 students. How come? 1, 2, 3, and 2 boys. 1, 2. Among those 3 girls, we have picked 2 girls. We have picked 2 girls. Now, these 3 students can be sit in any order, so we can say that it's 3 factorial. The final answer is 3 into 3 factorial into 2. So that is equals to 36. It's your second part answer. And for part C, the girl sits together and the boy sits together. 1, 2, 3, 4, 5. Let's suppose we are saying that boy sits together. So that is my first boy, that is my second boy. These 2 boys are sits together and these 3 girls are sits together, right? Now the placement of boy among those, that is boy 1, boy 2, and you can say that on the first place we have boy 2 and boy 1. So inside that box you have 2 factorial. Similarly, inside that box of girls you have 3 factorial, right? And these 2 places can be swept as well. You can say that at first we have 3 girls and then we have 2 boys, right? So the final answer will be, for boys we have 2 factorial, for girls we have 3 factorial, and for their placement we have 2 options, right? The first option I had drawn here. The second option will be like 1, 2, 3, 4, 5. The second option will be like we have 3 girls and we have 2 boys. Alright, so the final answer it was 2 factorial is 2, 3 factorial is 6 times 2 leads to 24. That is your final answer. Alright class, so I hope that it is clear to you and now you have an idea how to solve such questions which